This is MSJ Chem, and in this video I'm going to look at the physical and chemical properties of the group 17 elements, the halogens. The halogens, which means salt formers, are very reactive nonmetals. They are colored. Chlorine is a yellow-green gas, which you can see at the top here. Bromine is a reddish-brown liquid, which you can see in the middle, and iodine is a purple solid, which you can see at the bottom. They show a change from gases to liquid to solid as the molar mass increases down the group. The halogens are diatomic. They form molecules composed of two atoms. Here we have a molecule of chlorine. As you can see, it's formed from two atoms of chlorine joined by a covalent bond. Next, we'll have a look at the reactivity of the halogens. So reactivity decreases down a group. So fluorine is the most reactive and iodine is the least reactive. So reactivity decreases down the group. Let's have a look at the reason for this. The halogens react by gaining one electron to form negative ions. As the atomic radius increases down the group, which means more occupied energy levels, the attraction for the extra electron decreases. Another reason is the increasing number of occupied energy levels also increases the electron shielding between the nucleus and the outer energy level, and that also decreases the attraction for the extra electron. Next, we'll have a look at the reactions of the halogens. Group 17 elements react with the group 1 metals to form salts. So here we have sodium reacting with chlorine to form sodium chloride, and here lithium reacts with fluorine to form lithium fluoride. An ionic bond is formed between the metal, sodium, and non-metal, chlorine. Next, we look at the displacement reactions of the halogens. So the more reactive halogen displaces the ions of the less reactive halogen from solution. In the first reaction, chlorine is displacing the bromide ions from solution, and the chloride ions are going into solution. In the second reaction, chlorine is displacing the iodide ions from solution, and chlorine is going into solution. The first two reactions occur because chlorine is more reactive than bromine and iodine, so chlorine is able to displace the ions of the less reactive halogen from solution. In the third example, chlorine is unable to displace the fluoride ions from solution because fluorine is more reactive than chlorine. Therefore, we have no reaction. Chlorine will displace bromide and iodide ions from solution, but not fluoride ions. Next, we'll have a look at the reactivity of bromine. Bromine is able to displace the iodide ions from solution because bromine is more reactive than iodine. In the second example, bromine is unable to displace the chloride ions from solution because chlorine is more reactive than bromine, so therefore we have no reaction. Bromine can displace iodide ions from solution, but not chloride ions. And in our final example, we can see that iodine cannot displace bromide ions from solution because bromine is more reactive than iodine, and iodine is the least reactive of the halogens, so we have no reaction. So iodine cannot displace bromide or chloride ions from solution. And finally, fluorine. Fluorine is the most reactive halogen, therefore it can displace all the other halide ions, that's the chloride ion, the bromide ion, and the iodide ion from solution. None of the other halogens can displace fluoride ions from solution.